because most of the beginning of the notes it's just that she's talking. So, Friday and yesterday, the section 6.2 was saying, okay, you have a quadrilateral, it is a parallelogram, okay? That's what it said. You started with the parallelogram, and then the theorems that we talked about, 4 of the 5 theorems that we wrote down on Friday, we're telling you, if you have a parallelogram, if a shape is a parallelogram, then 4 things, okay? 1, the opposite sides are congruent. 2, the opposite angles are congruent. 3, the consecutive angles are supplementary. And 4, the diagonals bisect each other. So, section 6.2 is starting with a parallelogram and saying, if it's a parallelogram, then these things are true. Okay? Today's just doing the opposite. It's saying, if you have a shape that has opposite sides congruent, like theorem 6.8 says. So I have a shape and I say, oh look, these sides are congruent and these sides are congruent. If that's true, then it has to be a parallelogram. Theorem 6.9, it's the consecutive angle supplementary converse, except the way that it's worded says, okay, if you have an angle and you know that it is supplementary to both of its consecutive angles, the angles right next to it, then it's a parallelogram. Theorem 6.10 says if you have opposite angles are congruent, so you have a shape, these 2 angles are congruent and these 2 angles are congruent, then it has to be a parallelogram. And theorem 6.11 says, okay, you have a shape and you have its diagonals bisect each other. If that's true, then it has to be a parallelogram. Now, those were the 4 that we, the opposite, I guess, of the 4 that we talked about on Friday and yesterday. And then there's an extra one here that says, okay, let's say you have a figure. And actually, they got these shapes flipped around, but that's okay. So you have a figure, and you have these opposite sides, okay? These opposite sides are congruent, and they're parallel. Now, the big thing with this one is it has to be the same set of sides. So it would have to be, like in this picture, it says, okay, the top and the bottom, they're congruent, and they're parallel. If that's true, that's enough to prove that it's a parallelogram. Now, you have to be careful, because you couldn't say, like, these are parallel, and these are congruent. That's not enough to say that it's a parallelogram. It would have to be the top and the bottom are parallel and congruent, or the sides are parallel and congruent. Okay? So a big part of what we're doing today is we are going to use that information to decide, given this much information, can I say for sure, yes, it is a parallelogram. Now, what I will tell you, a lot of the things in this section rely on previous information, and it took me a little bit to kind of catch on to that as well. So actually, last class we learned together. You're very patient with me. Second hour, you better praise the Lord. You're not in second hour because that was the worst lesson for sure. Anyway, so what we want to do is we want to look at these 3 figures, and we want to decide, can I prove that the quadrilateral is a parallelogram based on the information? Okay. So, for this first one, this is the tricky one. This is the one that got me in second hour. We had to talk about it. Actually, I had to look at the answer. But, okay. So, in this one, if you look at it right off the bat, I know that angle A is 50 and angle D is 130. Okay, so, these angles are supplementary, right? So, what I was thinking whenever I first went through and made my notes is I'm thinking, oh, well, then I could apply theorem 6.9. Now, the problem is with theorem 6.9, you're saying if an angle is supplementary to both of its consecutive angles. It doesn't tell me that. Maybe it kind of looks like it is. But if I were going to use theorem 6.9, I would need to know either angle B or angle C. Okay, so to use theorem 6.9, you have to have 3 angles. Because you would have to be able to say, okay, this angle is supplementary to both of these. So I don't have enough information there. Okay? Also notice that I know AB is 5 and BC is 5. So I do know that these sides are congruent. So I may be thinking, well, I can use theorem 6.8. Problem is, theorem 6.8 says if both pairs are congruent, and they didn't give me both pairs. Okay, so here's where the prior information comes from. Okay, so this is back in, I think, chapter 2 or 3, when we talked about parallel lines. Very fond memories. I know you guys love the parallel lines chapter. So we learned about all of these relationships whenever you have parallel lines cut by a transversal. We had the same side interior, alternate exterior, all of the corresponding angles, all of those things. You guys remember that? So we first learned that, okay, if you have parallel lines cut by a transversal, if then alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are something. We had all of these relationships. Now here's the thing. What I don't know is I don't know that these are parallel. So a couple sections later, we learned, well, here's how you can prove that lines are parallel. If you have same side interior angles that are supplementary, which these are, then these lines have to be parallel. I know it's been a while since we've done that. But what I can do is I can use that theorem to prove that AB is parallel to DC. Because these are supplementary, those lines have to be parallel. Okay, we had a theorem, like I said, a couple chapters ago. Now, here's what I have now. I now have parallel lines that are also congruent. You see that? So, we could use this last theorem here, this theorem 612, to prove that this is a parallelogram. So, in this one, using a little bit of previous information, yes, I have enough information to prove that that's a parallelogram because I have an opposite side that is both parallel and congruent. That's probably the hardest one. Okay, the next one. Notice I have HK is congruent to HI, and I have IJ congruent to JK. So I have two sets of congruent sides. So I'm kind of thinking this is the one that talked about congruent sides, and theorem 6a says if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Is this picture showing me that opposite sides are congruent? No. Right? These are, I guess you could call them consecutive sides, right? If we were going to say that this is congruent by that first theorem, it would have to be this side congruent to this side, and it's not. And this side congruent to this side. So this one we'd have to say no. Not enough information there. Okay. And then this last one here can be kind of like that first one. So this one says that we have DE parallel to GF, and we have DG congruent to EF. So I have one side that's parallel and one side that's congruent. So that is kind of like theorem 612. Theorem 612 says that one pair of opposite sides is both congruent and parallel, then it's a parallelogram. Do I have one pair that is both congruent and parallel? No. Right? Because one of them's parallel and one of them's congruent. If you were going to use theorem 612, it has to be the same side as congruent and parallel, so that one, we wouldn't have enough information to prove that's a parallelogram now. Okay, let's get this glued into page 7. This is section 6.3, and it is proving that a quadrilateral is a parallelogram. Alright, so, like I mentioned before, today we're not starting with the parallelogram, we're starting with the quadrilateral, and we're trying to say, okay, if it was a parallelogram, this would have to be true. So, we are finding the values of x and y, so let's draw a parallelogram. That was not a very good parallelogram, but that's okay. Thank you. Okay, and then we're going to actually draw the diagonals of this parallelogram. Now, the information they're going to give me is they're going to say that this segment is congruent to this segment. They tell me that with the markings. And then they're going to tell me that this is 3x and this is 4x minus 5. Now remember, I don't know it's a parallelogram. I'm trying to say if this need to be? Well, if I'm given the diagonals of a parallelogram, what do I know about the diagonals? If this was a parallelogram, what would I know about the diagonals? So what would I know about the diagonals of a parallelogram? They bisect each other. Now, I know that this diagonal is cut in half because they tell me that. So if this diagonal was cut in half, yeah, then these would be equal. So that's exactly what you're going to do. So we're going to take 3x equals 4x minus 5. If it was a parallelogram, those would have to be the same. So if I solve for x, subtract 4x from both sides, we'd have negative x equals negative 5, which means x equals 5. Okay, number 2, let's draw another parallelogram. I'll try to do better this time. Let's see, maybe. There we go. Very wide parallelogram, doesn't have to be. Okay, now, this top left corner is going to be 4x plus 13. The top right corner is going to be 3y minus 2. The bottom right corner is going to be y plus 10. And the bottom left corner is going to be 12x plus 7. Now, once again, I'm trying to say, okay, if this was a parallelogram, what I'm trying to find is what would x and y need to be. So this time I'm given the angles of a parallelogram. What do we know about the angles of a parallelogram? Okay, the consecutive angles are supplementary. They add to be 180. So if I were to add these, I could set them equal to 180. I could add these and set them equal to 180, or I could add these and set them equal to 180, or I could add these and set them equal to 180, okay? What else do I know about the angles of a parallelogram? The opposite angles are congruent. Yeah. So there's kind of a couple ways you could solve for x and y. One of them's going to be easier than the other. If we start with the opposite angles, I could say, well, I know 4x plus 13 equals y plus 10, and 12x plus 7 equals 3y minus 2. If I do that, notice that both of the equations both have x's and y's, which means I'd have to solve using a system of equations. Not a big deal. We did that last section, but we can avoid that. That might be nice. If we do the other one where we said consecutive angles are supplementary, notice I would take 4x plus 13 plus 12x plus 7. See how there's only x's in that one? So I could solve for x. I wouldn't have to do a system of equations. So let's do that. Let's say, okay, 4x plus 13 plus 12x plus 7. Those are consecutive angles. They are supplementary, which means they would have to equal 180, add to be 180. So I can combine my x's. 4x plus 12x is 16x. 13 plus 7 is 20, which equals 180. Subtract 20 from both sides. We'd have 16x equals 160. Divide by 16, we get x equals 10. Now we still have to find y, but notice the same thing's going to happen over here. 3y minus 2 plus y plus 10. See how they both have y's in them? I could do that. I could do 3y minus 2 plus y plus 10. They would also have to equal 180. 3y plus y is 4y. Negative 2 plus 10 is plus 8, which equals 180. Two-step equation, so subtract 8. So 4y equals 172. And divide by 4, we should get y equals 43. Okay, questions on that one? Okay, let's do number 3. So another parallelogram. or I guess we don't know it's a parallelogram yet. We're trying to prove, I guess, that it's a parallelogram. Now this time we're going to say the top is 2y plus 2. The right side is y plus 4. The bottom is 3y minus 9. And the left is 3x plus 6. Now for this one, if this was a parallelogram, what do I know about the sides of a parallelogram? They're congruent. Opposite sides are congruent, right? So the top and the bottom are congruent, the left and the right are congruent. Now here's the thing. If I set the left and the right congruent, I would have 3x plus 6 equals y plus 4. One has an x, one has a y. Maybe think in a system of equations. So if you look at the top and the bottom, see how you would take 2y plus 2 equals 3y minus 9. See how they both have y's? Start with that one, because you can find y. So we're going to take 2y plus 2 equals 3y minus 9. Okay, to solve for y, we're going to move our y's together, so subtract 2y from both sides. So we'd have 2 equals y minus 9. Add 9, we should get y equals 11. Now to solve for x, I would take 3x plus 6 equals y plus 4, which is a problem because I have x's and y's. But it's not a problem because what do I know? I know that y equals 11. So if y is 11, then this side is what? 15. 11 plus 4. That side's 15, and these sides are congruent. So 3x plus 6 equals 15. Subtract 6, we have 3x equals 9. Divide by 3, we should get x equals 3. Okay, let's do one more of these. All right, number 4, another parallelogram. And you're surprised. And we're just going to do one diagonal, so let's do the top right down to the bottom left. Now the things they're going to give me for this one is we're going to say the left side is congruent to the right side. And this angle right here is going to be 10x minus 16. And this angle right here is 4x plus 14. 4x plus 14. Now you have to apply one of those theorems that we've talked about above, because if this is a parallelogram, if it's a parallelogram, I either need both sets of opposite sides congruent, opposite angles congruent, consecutive angles supplementary, the diagonals bisect each other, or that last one said I need the same pair of sides, both congruent and parallel. Okay? The first 4, I don't have enough information to do that. But the last one, I know that this side is congruent to this side. So if I knew that these were parallel, that would be enough to prove that this is a parallelogram. So I need to decide, well, how could I prove that these are parallel lines? Okay, so if I set these equal to each other, which means they would be congruent angles, it would prove that the lines are parallel. How does that prove that those lines are parallel? Excellent. This is a transversal. And if I have, what kind of angles are these? Alternate interior angles. And if I have lines cut by a transversal and alternate interior angles are congruent, then the lines would have to be parallel. So in order for those lines to be parallel, 10x minus 16 would have to equal 4x plus 14. Those angles would have to be congruent. So if I move my x's together, subtract 4x from both sides, so we have 6x minus 16 equals 14. Add 16 to both sides, so 6x equals 30. Divide by 6, we should get x equals 5. Now, this last one relies on a lot, one that I had to go back and look at the notes to figure out how to do this. So, okay, we're going to draw a parallelogram in a TH math. So clever. Okay, so parallelogram. Here we go. Okay, so the bottom left is going to be M-A-T-H. Okay, we're actually going to draw diagonals, and they are going to intersect at K. And a bunch of other information here. Okay, so we're going to have TH is 6, MK is 3.5, AK is 3, and AKT is a right angle. And we're going to find 6 things. So we're going to go ahead and write down all these things, and then we're going to come back and talk about how we know what they are. So we're going to do 5, 6, 7, 8, 9, 10. Okay, so number 5, we're going to find M-A. 6, we're going to find M-H. 7, we're going to find K-H. 8, I want to find the measure of angle T-H-M. 9, I want to find the measure of angle H-M-A. And number 10, I want to find the measure of angle A-T-M. Okay, and then the other information they did throw out there, the measure of angle MAT, so this angle right here, is 113. Now they also tell me it is a parallelogram, okay? So if we know it's a parallelogram, all those theorems that the diagonals bisect each other, the opposite sides are congruent, the opposite angles are congruent, all of those things, we know that's true because they already tell me it is a parallelogram. So if I wanted to find MA, what's MA? 6. Opposite sides. It is a parallelogram, so I know that opposite sides are congruent, so I know it's 6. Now, here's where the prior information comes in. Okay, because I want to find MH. Okay, I know MH is congruent to AT, but the problem is, okay, I don't know what AT is. Okay, so we're going to take this back. I think it was in the last chapter. I think it was in chapter 5. Okay. What I want to do is I want to talk about, okay, let's say I'm going to talk about point T and point M. Okay, so what I have here is I have a line, AM, and I have a line, AT. Now, I know that MK and KT, I know that they're congruent, right? Because it's a parallelogram, and that's a diagonal, so I know those are congruent. Do we agree on that? I know that these are congruent, right? Okay, so coming back to this, so I have these lines. A couple chapters ago, or maybe it was in the last chapter, we talked about, okay, you have this angle, you have these points on the angle. If these points are equidistant to a point in the middle, okay? Remember we also talked about the distance from a line to a point? And we said, okay, if you're going to go from a line to a point, it has to form a right angle. It has to be perpendicular, straight to it. Okay? And that's what's happening here. Okay? What happens is this right here is on the angle bisector, and then if you went the other way and said, okay, you have this point that's equidistant, then these are equidistant from the vertex. And all of these things, they were kind of confusing. Basically what I know, that since these are equidistant, this is an angle bisector, and these are congruent. Which means if AT is congruent to MA, MH is also going to be congruent, right? So, what is MH? 6. They're all going to be 6. All of those sides are going to be 6. And then if we want to do KH, kind of already labeled it here. What is KH? We're going to be the same as that one, right? Because it's a second bisector. It's going to be 3. Okay, what about the measure of angle THM? THM, it's going to be that big angle here. What would that be? Yeah, opposite angles, right? It's going to be 113. So, angle HMA, how would I find angle HMA? 180 minus 113, right? So 180 minus 113 would give me 67. And then to find the measure of angle ATM. Okay, so that's going to be this little angle right here. Now remember what I talked about, that if this point is equidistant, which it is, from points on the race, this is an angle bisector. So if I know this whole thing is 67, what's just half of it? Half of it, I guess I'm going the other way, right? You would just take that divided by 2. You have 33.5. Lots of prior information there. Okay, the one in your homework is going to be super